A sequence is given by a sub 1, followed by a sub 2, followed by 25, 32, 39, all the way to 207. How many terms are in this sequence? So the first thing we need to determine is on the sequences in series is this a arithmetic sequence or is it a geometric sequence? Now remember, arithmetic means you're adding to get from one term to the next. That's why there's a plus there next to a1. Geometric, you're multiplying because that's what happens when you have a1 and another letter following next to each other. It means multiplication. And also you could say this means it could be subtracting, its opposite, or here dividing. Okay, let's look. What's happening from one term to the next? I believe this is adding by 7. Let's check it. Does it keep adding by 7? Yes, they add by 7. So this is arithmetic. And because it's arithmetic, it'll follow that arithmetic formula, which is shown here. Now, this one's asking how many terms. It's not asking for a sum. Now, remember, if it was a sum, you would substitute this out with sigma. If it was a sum, you would replace. But this is not a sum, so we're actually not doing that at all. We're going to use this formula. And so let's plug in what we know. We can refer to this here as the last term, so this is a sub n. We do not know a sub 1 or a sub 2, but I can call this a sub 3. Now here's the beauty of using that formula. The top formulas here, and here. And these two formulas can work special. You don't have to have the first terms here. So what we can actually do is we can replace this a sub 1, and I can actually say this is the same thing as a sub n equals a sub 3 plus n minus 3 times the difference. As long as this number here and this number stay the same, I can do this in the formula. So let's substitute in. A sub n, we're going to say, is 207. So 207 goes here. A sub 3 is 25. Plus, we do not know our n, that's what we're trying to solve for. We do know the difference is 7. So 7 goes there. Now, if you wanted to, you could n solve this. That's all you would have to do. And so I could come over here and just say menu 3(1), which will give us n solve, and we'll have that other parenthesis that naturally comes at the very end. And all you do is comma n. That would solve it from there. That's it, how you would type in the calculator. Well, we'll check that in a second, but first let's just try the algebra on our own. What you would do is I'm going to subtract the 25, and I'll also distribute this. I'll do two steps at once. So I'm going to go distribute, distribute, and I'm going to subtract 25. So when I subtract 25 here, I'm left with 182. That gives me 2. That's an 8. Change that to a 1. Distribute, distribute. So 7n minus 21. Well, now what am I going to do? I'm going to add the 21. Whoops, add 21 on 27. Add 21. So this should be on the right side, 203. This becomes a 3. That becomes a 0. You add the 1 there. That's 203 equals 7n. Now, hopefully, when we divide by 7, we get a whole number. It should be, I believe, 29. We'll check that in the calculator by n solving this whole thing. 7 will go into 20 twice. The remainder is 6. 7 would go into 63 then, 9 times. So I believe the answer is going to be 29. And so I'm going to bubble that in, and then we'll n solve it. We'll check our work in from the calculator. So I'll put 29 here. And now let's go check with that n solve. Remember how I said we can n solve this step? So I'll come over here, and let me just clear this all off so we can see what we're doing. Calculator, I go mini 3(1) for n solve. It was 207 equaled that first term, which is technically the third term, plus, and we said n minus 3 since it was the third term, times 7. Now remember, this is the natural parentheses that they give us. You need to do the comma n on the inside. I get 29, so that is in fact the right answer. We've done it correctly.